Alright, so now I'll be solving one last practice problem for nodal analysis before we move on to our next topic, which is related to nodal analysis too. But this is a circuit and we need to find the nodal voltages of all nodes. So the first step is to mark out all the nodes. One thing to remember is that do not get confused by this Vx because this is not a nodal voltage. This is just the potential difference across the 4 ohms resistor. So I'll just mark out all the nodes. This is my first node, this is clearly my second node, and this is my third node. So by inspection I can see that both node A or node C, they have around they have 3 branches connected to them. So I'll just choose one as the reference node. So in my opinion the reference node should be node C. So node C is the reference here. So that means I need to find VA, I need to find VB, and VC is clearly 0 volts because that is the reference right now. So I'll start writing the nodal voltages at all nodes. So VA, one thing to note is that VA stretches from this entire area. All of this is VA. So it is very important to take into consideration all the branches when you're writing the KCL. So I'll just start off from the top. I'll just assume there's a current entering here. So I'll write VC minus VA divided by 4 because I'm assuming that the current is flowing from C to A. So VC comes first and then VA. And there is this current flowing into node A, but it's actually leaving, so I'll write minus 3 Vx because it is leaving the node. And there is this third branch, this one, and there is a current entering node A from the VB direction, so I write VB over F over divided by 3. So now I write the same for node D, and that would make it, there are 2 branches, there's one current coming here and there's one current coming here, both are entering. So I'll just write VA minus VB divided by 3, and there's this other current coming from VC, so plus VC minus VB divided by 2, and these are the 2 voltages. Now there is the same problem that came in the last question is still here, and that is there are 3 unknowns, VA or VB and then Vx. So we need to somehow manipulate Vx into a form that consists the nodal voltages. So as I can see, Vx is clearly Va minus Vc. So I can just write Vx is equal to Va minus Vc. And now you can substitute this into this equation, and then you would have 2 equations with 2 unknowns, so you can solve that. So I won't really go into solving these entire equations, and this was just an example to basically strengthen the concepts of how dependent current sources are dealt with in nodal analysis. So I hope this makes things more clear now.